In part 3 of our lesson on graphs of tangent and cotangent, we're going to graph translations of tangent and cotangent. So first let's look at a summary of how to find the period, vertical stretch or compression, phase shift, and vertical shift. Here's the standard form of the function equations for tangent and cotangent. Now the absolute value of A is going to tell us the vertical stretch or compression. Remember, for sine and cosine, the absolute value of A gave us the amplitude. But because tangent and cotangent are infinite, their ranges go from negative infinity to positive infinity, you can't really say something has an amplitude when it's infinite. One thing can't be more infinite or less infinite than another thing. So the absolute value of A functionally will still do the same thing, and it gives us the vertical stretch or compression of the graph. Period is found by calculating pi over b, and that will give us the horizontal stretch or compression of the graph. Now remember that the period for unaltered tangent and cotangent is pi, so for sine and cosine we were putting 2 pi over b, but for tangent and cotangent the period is pi over b. Phase shift still comes from letter C, and it's done the same way. C is what comes after the minus sign. So if C is positive, that will be a shift to the right. So remember, if C is positive, then that means it will look like x minus pi over 6, for example. That means C is positive. If C is negative, it will look like x plus pi over 6, because what really is happening is x minus negative pi over 6. And as before, letter D is going to give us the vertical shift because D comes after a plus sign. When D is positive, it will be a shift up. When D is negative, it will be a shift down. Here now are the steps for creating graphs of tangent and cotangent. First, we'll find the formula for all the vertical asymptotes, and then we'll use it to find the two vertical asymptotes on the graph. We discovered that for tangent, the normal places where the vertical asymptotes are is pi over 2 plus n pi. So you'll take the argument of your tangent function and set it equal to that, and then we'll plug in n is negative 1 and 0 to find the vertical asymptotes of the one cycle. For cotangent, we'll solve the argument equals n pi, because n pi is the place where normally the vertical asymptotes happen, and we found you have to plug in 0 and 1 for n to get the one cycle vertical asymptotes. In both of these equations, you can use either form of the argument. You can use the factored form of the argument, or you can use the unfactored form of the argument because they're equivalent to each other. So either of these can go in for the argument in either equation. Second, you'll solve the inequality to find the shifted cycle, just like we did for sine and cosine. Now here's a big difference though. Tangent and cotangent don't go 0 to 2 pi like sine and cosine did. Tangent, if you remember, goes from negative pi over 2 to positive pi over 2, where cotangent goes from 0 to pi. So that's a difference. And again, anywhere you see the argument, you can use the factored or unfactored form. Third, you'll find the period, vertical stretch or compression, phase shift, and vertical shift of the graph. Fourth, you'll break the shifted cycle into 4 equal pieces and plot the 5 key values. Now, 2 of the key values are going to be vertical asymptotes, which you'll already have figured out. So you'll only have 3 points that you'll have to plug in and figure out what they are. All right, so let's get started on a graph. In this example, we have to sketch one period of the graph of y equals 3 tangent of 2x minus pi over 4. So first, we need to find the formula for all the vertical asymptotes, and we know that in order to do that, we take the argument of the function and we set it equal to where the normal vertical asymptotes happen. Now, because this is a tangent function, we know that those asymptotes occur at pi over 2 plus n pi. The argument of the function is 2x minus pi over 4. So first order of business, we're solving for x, so we'll add pi over 4 to both sides. The left-hand side becomes 2x. Now the right-hand side, we see that pi over 2 is going to be the same as 2 pi over 4, of course. So 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. And we have that plus n pi. My recommendation is to get the common denominator of the right-hand side, so we'll leave the left-hand side alone for right now. The common denominator on the right-hand side is 4. We would have to multiply the n pi times 4 over 4, and the numerator becomes 3 pi plus 4n pi. Denominator is 4. Now we can divide both sides by 2 or think of it as multiplying times 1/2, probably a safer bet here. And we get x is equal to, now this 2 would have to cancel in both terms of the numerator, and it cannot, so there's no canceling that can take place. Be sure you don't make that common error where you think you can cancel the 2 with this 4. They do not cancel because you cannot also cancel it with the 3. So we get x is equal to 3 pi plus 4n pi over 8. And this is our formula which finds all the vertical asymptotes of this function. We're always going to want to use this formula to find the 2 asymptotes of our one period. And we know for tangent that we want to plug in n is -1 and n is 0. So we'll plug in -1, we'll plug in 0. If we plug in -1 for n down here, this becomes a minus 4 pi. So we have 3 pi minus 4 pi would be negative pi over 8. If we put a 0 in for the n, of course that wipes out this term, and we get 3 pi over 8. Next, we'll solve the inequality for the shifted cycle. For tangent, we know that we have to put the argument in an inequality between negative pi over 2 and positive pi over 2. So in this case, we'll say negative pi over 2 is less than 2x minus pi over 4 is less than pi over 2. We're going to need to add pi over 4 to all three pieces of the inequality. Negative pi over 2 is, of course, negative 2 pi over 4. So negative 2 pi over 4 plus pi over 4 is negative pi over 4. The middle becomes 2x, and the right side, we know pi over 2 is 2 pi over 4. So 2 pi over 4 plus pi over 4 is 3 pi over 4. We'll need to multiply each piece of the inequality by 1/2 to solve for x. And we get that negative pi over 8 is less than x is less than 3 pi over 8. And you can feel pretty confident because that's exactly what we said with our asymptotes should happen. Remember that for the graph of tangent, the first of the 5 key values is an asymptote, and the last of the 5 key values is an asymptote. So this is agreeing with what we expected to get for our asymptotes. Next, we'll want to find all these attributes about the graph, and in order to do that, we want to write the function in the standard form. So let's take this and go ahead and factor out the 2. So we're going to get 3 times the tangent of 2 times the quantity x minus. Now remember, think of dividing by 2, or in other words, multiplying by a half. A half times 2x became x, and a half times pi over 4 becomes pi over 8. And you should always check it out. 2 times x is 2x. 2 times pi over 8 is pi over 4. Now it's easy for us to see a, b, c, and d. We know to find the period, we need to do pi over b. And remember, that's a difference for tangent and cotangent. That's different than sine and cosine. Sine and cosine was 2 pi over b. Tangent and cotangent is pi over b. So this becomes pi divided by 2. Nothing to reduce, so that is our period. The vertical stretch or compression is the absolute value of A, which is the absolute value of 3, which is 3. The phase shift is equal to C, and in this case, C is positive because remember, it's what comes after the minus sign. So C is a positive pi over 8, which means it's going to the right. The vertical shift is letter D, and in this case, there is no vertical shift because D is equal to 0. Now the domain, remember the relationship between the domain and the vertical asymptotes. Wherever the x values of the vertical asymptotes are, those are the x values where the function cannot be. The domain we get for free. So x cannot equal 3 pi plus 4n pi over 8. And the range we know for tangent and cotangent both, The range is all real numbers, so we're going to get negative infinity to positive infinity. So these are the attributes of the graph that we're expecting. So once we make our graph, we'll double check all these and make sure that it came true. We're ready to move on now and find the 5 key values of the graph. Now recall that when we solved the inequality for the shifted cycle, we found out that our one period is going to start at negative pi over 8, and it's going to end at 3 pi over 8. So using the start value and the end value, we can now find the midpoint. So we add them up and divide by 2, which is just multiplying by 1/2. So we've got 1/2 of the quantity negative pi over 8 plus 3 pi over 8, which is 1/2 of 2 pi over 8, which is equal to pi over 8. The quarter point will be halfway between negative pi over 8 and positive pi over 8, so that's easy to see that it's going to be 0. And now we can also see that the graph is going up by pi over 8 every time. So up by pi over 8, up by pi over 8, which means the 3/4 point we'd have to go by pi over 8 more. So we're at 1 pi over 8. So then the 3/4 point is going to be 2 pi over 8. So now we have all of our x values, and we're ready to figure out our expected y values. Now for a tangent graph, we know that the start and the end already are vertical asymptotes. We've already figured that out, so we can just go ahead and write those in. Now the other 3 values, we expect that tangent would go -1, 0, and then 1. So we know that our y values are going to be affected by letter A and letter D. A is equal to 3, and we know D is equal to 0, so there's no shift. So now we can go ahead and figure out our y values. We just have to take every y value and multiply times 3. So this is going to become -3, 0, and +3. It's time to check at least one value. We can do this first one if we like. I wouldn't do the one that's 0 because remember, you could have the graph upside down and you wouldn't catch it. So we'll do this first one. We're going to take 0, which is our favorite number to plug into anything, and plug it in for x, either here or here. Again, it doesn't matter which form of these equations you use because they're equivalent. I'd probably be tempted to use this one this time because once I put the 0 in here, I can very easily see what the argument will be. So if we take the 0 and plop it in for the x here, we're going to get 3 times the tangent of 0 minus pi over 4, so this becomes negative pi over 4. We know that the tangent of negative pi over 4 is -1, so this works out to be -3, which is exactly what we were expecting. So now we're ready to plot our graph. We know the 5 key values are at negative pi over 8, there'll be a vertical asymptote. Then we're plotting the point 0, 3, pi over 8, 0, and 2 pi over 8, 3, and then it ends with the vertical asymptote there. So let's make our graph. We can see that our x scale is that we're going to want to go by pi over 8. So we've got negative pi over 8, 0, positive pi over 8, 2 pi over 8, and 3 pi over 8. Our y values have to go from negative 3 up to positive 3, so looks like we'll probably want to go by ones. We know at negative pi over 8, we're going to have a vertical asymptote. Same for 3 pi over 8. And then our other three key values are 0, negative 3, pi over 8, 0, and 2 pi over 8, 3. Just a reminder that my suggestion to you is to start out at this middle value and draw one smooth curve approaching the asymptote, then start out again at the middle value and draw the other smooth curve. Last, we're going to want to check all these attributes. So if we look at the graph, 3 pi over 8 minus negative pi over 8 would become 4 pi over 8, which is pi over 2, so our period checked out. The vertical stretch has to be 3, and that makes sense because normally these would be at negative 1 and positive 1, so the vertical stretch was 3. The phase shift had to be pi over 8 to the right. Now when we look at the graph of unaltered tangent, we know that at the y-axis should be where that center value happens, the root. And instead, that root has moved over to the right by pi over 8, so that checks out. And the vertical shift checks out to be none because we end up right here with that middle point right on the x-axis. So there's our graph of this tangent function.